Welcome you all. I am Karthik Gupta. Today we are going to discuss the topic called problems on trains. Okay. So problems on trains, time and distance, actually speaking, both are same. But the syllabus is very huge. Because of that reason, we have bifurcated time and distance as a separate part and problems on trains as a separate part. But the concepts what we are going to use in both the modules are same and similar. Okay, so now problems on trains. See here, whichever the exam you may take, whether it may be clerical, PO or SO, one problem or two problems you can expect from this module, and the problems will be very simple compared to your time and distance. But only the thing is, you have to analyze how to take the distance or how to consider the distance in this module. Okay, so now problems on trains, very simple. See here, whatever the concepts we have discussed in time and distance, the same concepts are applied here also. The speed is inversely proportional to time and speed is directly proportional to distance. So the formula what we use here is speed is equal to distance by time. Speed is equal to distance by time. So this is the formula what we are going to use here also. But one thing you have to analyze. See here, what is the distance travelled by a train if the length of the train is 100 meters which crosses the pole in 10 seconds. Okay, they are going to ask you the question like this. The length of the train is 100 meters. The length of the train is 100 meters which crosses a pole in 10 seconds. So what is the length of the train? So consider there is a pole. In front of that pole, a train is going to pass. See here, a train is going to pass in front of the pole. So the pole is standing and the train is moving. If you consider that the train is not moving and the pole is moving, then the entire pole or the pole has to travel the entire length of the train. See here, let me tell you again, a pole is there. Okay, in front of that pole, a train is moving. Now, pole is a standing object which is not having any movement. But train is a object which is having a movement. So train is passing in front of the pole. If you consider that the train has stopped, train is having no movement and the pole is having the movement, then the pole is going to move or the pole is going to travel entire the length of the train, or it is going to travel the length of the train. Therefore, here the distance will be length of the train. In your exam, they may ask you the question like this. A train is passing in front of the pole, the train is passing in front of the man, the train is passing in front of the electric pole. Okay, so these type of questions they are going to ask, where the distance is nothing but the length of the train. Why? Already I have explained. Here pole, in front of that pole, the train is going to pass. If you consider the train is not passing or the train is not moving, if the pole is moving, then the pole is going to move the entire distance, that is the length of the train. Okay, so therefore the distance travelled is nothing but the length of the train. Okay, so distance is equal to length of the train when it is going to passes an electric pole or a standing man. Okay, now you are going to get one more condition. The condition is like this. And train is going to pass as a platform. See here, there is a platform which is not having any movement. So in front of that platform, the train is going to enter. So now, what is the total distance travelled by time? See here, the train, the first bogie of the train is going to enter, the next, the second bogie, the third bogie, fourth bogie. Like that, when the first bogie has entered the platform, the last bogie has not entered the platform. When the first bogie is going to leave the platform, the last bogie is not going to leave the platform. Means what? Even though the bogies are passing the platform, but the entire train is not passing the platform. entire train is not passing the platform. See here, in front of the pole, the entire train is going to pass, means the pole is going to pass the entire train, that will be the total distance. But here, the entire platform, for example, 150 meters is the length of the platform. Let us take 150 meters is the length of the platform. The entire platform has to cross the entire train, or the entire train has to cross the entire platform. So here we are going to take the distance as, length of the train plus length of the platform. Okay, so the entire train has to pass the entire platform, therefore we are going to consider it as distance is equal to length of the train and length of the platform. If they are going to ask you the bridge, then distance will be length of the train plus length of the bridge. If they are going to tell you both the trains are moving, then total distance is equal to length of the train first plus length of the train second. Okay, so when you are going to get a negligible distance like pole or electric pole or a man, then we can neglect that distance and we are going to take only the length of the train. But when we get a considerable distance like the length of the platform, the length of the bridge, the length of the train, the length of the tunnel, then we are going to add the length of the train or the length of the tunnel, okay, the length of the bridge and length of the platform to the train. Okay, so the total distance will be length of the train and length of the platform, or length of the train plus length of the bridge, length of the train 1 or length of the train 2. So this is the different concept in trains when compared to time and distance. In time and distance, directly we are going to take the distance, but here we are going to consider the length of the two trains as the total distance. Other things are all same. The relative speed, the speed conversion, the time conversion, speed is equal to distance by time, the relationship between speed and time, each and everything is same, okay, except the distance. Here we are going to consider the distance in this manner. Okay, let us solve the problems. Problem number 1. A train covers 90 meters in passing a standing man. Find the length of the train. So already in the introductory class I have told you, in front of the man or in front of the electric pole, if the train passes, we have to consider the distance as the length of the train. So here the length of the train is 90 meters, or a train covers 90 meters. Okay, so distance is 90 meters. So distance is nothing but length of the train. Length of the train is nothing but the distance, so your answer is 90 meters. When it is crossing a negligible distance such as the man or a pole, okay, when it is crossing a such type of distances, then we are going to take the length of the train as the distance traveled. So here option D is the right answer. Okay, let's move on to the next problem. Problem number 2. A 30-meter long train passes a platform which is 150 meter long. Find the distance covered by train in passing the platform. So when it is going to cross the platform or bridge or tunnel or another train, we have to consider the distance as both their lengths. Okay, so distance is equal to length of the train plus length of the platform. So which is equal to 30-meter long train plus 150 meter long platform, which is equal to 180 meters. So option B is your right answer. Okay, option B is your right answer. So we have to add both the two, 30 meters plus 150, which is equal to 180. So when they are going to ask you to calculate the length of the train, the distance covered by the train when it is going to cross the platform or the tunnel or a bridge or the another train, okay, because both the lengths has to be considered to calculate the distance traveled. Okay, so that is 180 meters. Okay, let us take one more problem. Problem number 3. See here, a 220-meter long train passes a signal post. See, signal post is an important point here. Passes a signal post in 12 seconds. Find the speed of the train. Whether the train is passing a bridge, a tunnel or a platform or another train? No. It is going to pass a signal post. Signal post where the length is very negligible. So when it is going to cross a pole or a man or an electric pole, then the distance traveled will be equal to length of the train. Therefore, speed is equal to length of the train by time. Therefore, speed is equal to, what is the length of the train? 220 divided by 12. So which is in meter per second, but we have to calculate into kilometer per hour. From meter per second to kilometer per hour, if you want to convert, then we have to multiply it by 18 by 5. 18 by 5. So 6 2s are 12, 6 3s are 18, next 2 11s are 22, 110. So speed is equal to 110 into 3 by 5. So 5 2s are 10, 5 2s are 10, 22 into 3, 66. So your answer is 66 kilometer per hour. So option C is the right answer. See here, distance is length of the train, and other all the things are same. Whatever we have discussed in the time and distance, the same concepts are applied here also. If you want to convert from meter per second to kilometer per hour, then you have to multiply it by 18 by 5. 220 by 12 into 18 by 5. So after simplification, you are going to end up with 66 kilometer per hour. Okay, let's move on to the next problem. Problem number 4. A train traveling at a speed of 30 meter per second crosses a 600 meter long platform in 30 seconds. Find the length of the train. See here, a train traveling at 30 meter per second crosses a 600 long platform in 30 seconds. Find the length of the train. Find the length of the train. So here, total distance is equal to length of the train plus length of the platform, because when you are going to get the case like platform or the bridge or the tunnel or another train, we have to add with the train. Okay, so the total distance will be equal to length of the train plus length of the platform. So total distance is equal to length of the train plus length of the platform. Now speed is equal to distance by time. So speed means 30 meter per second, which is equal to distance, length of the train we don't know, plus length of the platform, that is 600, divided by time taken, that is 30 seconds. So now cross multiplication, 30 into 30 is equal to length of the train plus 600, 30 into 30, that is 900. So minus 600 is equal to length of the train. Therefore length of the train is equal to 900 minus 600, that is 300. That is 300. So option D, 300 meters is the right answer. See guys, one thing always you have to remember, distance is equal to length of the train plus length of the platform when they are going to give the considerable length of the platforms or bridge or the tunnel. At that time you have to add. So therefore speed is equal to distance by time. So here option D is the right answer. Okay, let's move on to the next problem, problem number 5. An 820 meter long train is running at 126 kilometer per hour. In how much time will it crosses a tunnel which is 580 meter long? See here, they have given the length of the train, they have given the length of the tunnel, and they have given the speed. We have to calculate the time. The distance is in meters, or the length of the train and tunnel is in meters. We want to calculate the time, which is in seconds. But how about the speed? Speed is in kilometer per hour. So what we have to do? We have to convert the speed kilometer per hour into meter per second. So therefore speed is equal to distance by time, whereas D is equal to length of the train plus length of the tunnel. Length of the tunnel. So speed 126 kilometer per hour has to be converted into meter per second into 5 by 18 is equal to distance means length of the train plus length of the tunnel, that is 820 plus 580 divided by time taken. So divided by time taken. See, 6 3s are 18, next 6 2s are 12, 6 1s are 6, 3 7s are 21, 7 into 5 35. So 35 is equal to 0 0, 8 plus 2 10, 1 carry over, 8 plus 6 14. So divided by T, therefore T is equal to 1400 divided by 35. So again see here, 7 5s are 35, 7 2s are 14, so 200 by 5, which is equal to 5 4s are 20, 40 seconds. So the answer is 40 seconds. Very simple. These type of problems you can expect in your clerical exam. Only the thing is you have to consider both the lengths, that is length of the train as well as the length of the tunnel. So length of the train plus length of the tunnel will be your total distance, and always we have to remember that length of the tunnel is a considerable distance. It is not like a signal post or the electrical pole or a man. Okay, so after simplifying we got 40 seconds as the answer. Let's move on to the next problem, problem number 6.